welcome back everybody. Welcome to Curriculum Edge's new video, How AI Uses Energy, What It Takes to Power Artificial Intelligence. Don't forget to like and subscribe to see more of our videos, as we greatly appreciate it. Welcome to our deep dive into the hidden power behind artificial intelligence. Today we'll uncover how AI consumes energy from training massive language models to handling billions of user queries, and why powering AI isn't just about servers, but also cooling, water, and the whole global energy infrastructure. AI lives in data centers, specialized facilities just for running computations. In 2022, global data centers consumed about 240 to 340 terawatt hours of electricity, roughly 1 to 1.3% of the global's energy demand. Including crypto and data transmission, it gets closer to 2%. Let's explain a bit more about what a crypto transaction is and why it's more complicated than a regular data transmission. In decentralized cryptocurrencies, computers must solve cryptographic puzzles to validate transactions and secure the network without a central authority like a bank. This process is called proof of work. It ensures that new blocks of transactions are added to the blockchains legitimately and in a trustless, transparent way. The puzzles are deliberately hard to solve but easy for the network to verify, balancing network security with honest participation. Each machine runs 24/7, which is why crypto's energy footprint is so high. Some blockchains are transitioning to proof of stake systems like Ethereum did in 2022. This cut its energy use by over 99%. In a proof of stake system, validators are chosen to verify transactions and add new blocks based on the amount of cryptocurrency they hold and are willing to stake as collateral. This takes less computational power than proof of work, which is usually used by solving puzzles. According to the IEA, electricity demands for data centers is projected to more than double by 2023. That's roughly Japan's entire electricity use today. In the United States, AI-fueled data center demand could amount for almost half of the country's electricity demand by 2030. In advanced economics, broadly, data centers could drive over 20% of electricity demand growth. Let's break down two phases, training and inference. Training big models like ChatGPT 3 uses massive amounts of energy, and each new model will require more computational power. Think of training an AI model like teaching a child to recognize animals. At first, you show them thousands of pictures: cats, dogs, birds, and elephants. Every time they make a mistake, calling a cat a dog, you gently correct them. Over time, they start to recognize patterns. Cats usually have pointy ears, dogs often have larger snouts, and so on. For AI, it's similar. Instead of children, it's computers. Instead of animals, it's millions of examples: words, pictures, or sounds. The computer guesses, gets correct, and then adjusts itself to do a little bit better next time. After repeating this process millions of times, it becomes really good at spotting patterns on its own. The catch? Unlike a child, these computers don't run on snacks and nap time. They need huge amounts of electricity to do that, the guessing and the correcting. That's what we mean when we talk about the energy cost of training an AI model. Now for the interface. Once trained, models still consume energy from every user prompt. For example, a single ChatGPT request uses 10 times more electricity than a standard Google search. Google Gemini AI team claims each prompt consumes less than 9 seconds of TV and uses 5 drops of water, achieving a 33% energy efficiency improvement in a year. Beyond electricity, data centers consume a staggering amount of water for cooling. Imagine running your laptop for hours on a hot summer day. It gets warm, right? Now imagine not one laptop, but thousands of super powerful computers all running in the same room. That room would feel like a furnace. Data centers are basically giant rooms full of these computers. And just like people need fans or air conditioning to stay cool, the machines need cooling too. Water is one of the best ways to pull away the heat quickly and keep everything from overheating. So when we say data centers use water cooling, It means they're using water as a giant efficient air cooler to keep the computers from melting down. We've talked about the cost of electricity and water cooling. Let's talk about the overall environmental factors. These processes also emit carbon dioxide. Whenever a computer uses electricity, that power has to come from somewhere. If the electricity comes from a clean source like wind or solar, that's great. But a lot of the time, the electricity is made by burning fuels like coal and natural gas. When those fuels burn, they release carbon dioxide into the air. It's a kind of like when you run a car engine. Exhaust comes out from the tailpipe. Data centers don't have tailpipes, but the power plants that feed them do. So the more energy our AI and data centers use, the more carbon dioxide gets released, unless that energy comes from clean, renewable sources. That's why people say AI has a carbon footprint. Now, this all sounds very scary, but there are things we can do to improve this. Efficiency methods include advanced cooling technologies, green site selection, such as selecting cooler sites like the Arctic or Scandinavian locations using outside air cooling. There's also GPU virtualization and smarter workload scheduling. We can already see there are many tech companies that are shifting to renewable energies. Google's data centers are carbon free around 64% of the time, with some sites over 90%. More work can continue to improve this across many other companies. Thank you for watching today, and now I hope that you consider how much every AI search costs. See you next week.